All right, the second lesson for today is 87, and it's solids of revolutions, the third part. So the first one, we used discs, where we just had solid discs that we summed up using the integral. The second method was washers. That's like an outer radius minus an inner radius, so you have a hole in it, and you use the integral to sum all of those up. Well, today we're going to use a method that's called shells, and I'll try to demonstrate the best I can what that is. But the volume of a shell, if you look on page 445 for a picture, then you get that the volume is the area, which is 2 pi r times h, times the width of the shell, which would be either delta x or delta y. Okay, so I'm going to try to demonstrate to you what's happening in a shell. So what happens is we have, if we start at the center of the shell, let's say this was the smallest shell that we could get. So it's round, okay? And as you go out and you make the radius get bigger and bigger and bigger, then you add all these shells up to where you get the shape. And the shape is like a solid cylinder, okay? So it's like this, solid cylinder. But the shell, again, it starts out being really small, like this is the round shell. And when the radius gets bigger and bigger, x keeps going out to the limit that they give us, the shells get bigger and bigger. So what we're doing is we're actually adding each little piece, each little shell up until we get the solid that's formed. I know that wasn't a very good example, but that's the best I can do. Thank you. Donna. All right. So on page 446, it says, the region bounded by the coordinate axes and the lines y equals 5 and x equals 3. So you know they always give us this weird one. Doesn't have a variable because it's always the same. So the coordinate axes, the lines y equals 5, 1, 2, 3, 4, that line, and the line x equals 3, 1, 2, 3. So we've got this region right here is revolved about the y-axis. So it's coming around like this. So our smallest shell is going to be right here. And then it'll increase. It'll be a bigger shell and a bigger shell and a bigger shell until we add them all up and it goes all the way out to x equals 3. So that tells me that my shells are going to be integrated from 0 to 3. From here to here. And here's the formula for the volume. So it's going to be a 2 pi times the radius in this case is x, because this is what's changing. It starts being really small and it goes over to x equals 3. So 2 pi times x. The height in this case doesn't change. The height is always 5, and that's what makes this problem a little bit weirder. And then the slices are vertical dx. All right, so we have actually the constants here, 2 pi times x. We can actually pull that out. 2 pi times 5 is 10 pi times the integral of x dx from 0 to 3, which will be 10 pi times the integral of x is x squared over 2 evaluated from 0 to 3. So that'll be 10 pi times 9 halves minus 0, which gives us what? 2 goes into 10, 5 times 9 is 45 pi. Okay, now we know that that's a cylinder. This was a cylinder. Okay, radius 3, height 5. So we know the formula for the volume of the cylinder is area of the base, which would be pi times the radius squared times the height, which is 5, which gives us what? 45 pi. Okay, so this one typically we probably wouldn't use an integral if we were just finding the volume of a cylinder, if we recognize that. But here is another alternative to finding it. All right, so now turn to page 447, example 87.2. Says the region bounded by y equals x minus 1. Okay, so let's see. The x-axis, so this line y equals x minus 1 would actually start down here and come up, but we're only concerned with this part of it, starting on the x-axis, going to x equals 4, so that's 1, 2, 3, 4. Here's 4. I just didn't do a very good job of drawing the x-axis, sorry. So this line is going up 1 over 1, up 1 over 1, right to there. So this region right here is revolved about the y-axis, so it's coming this way. So our slices will be like this. But our radius now, our integral is going to start from, this is the y, not the x. It's going to start not at 0 because there's nothing in here. There's a little hole in here. When this spins around, it's not going to start here. It's going to start here. So our integral's got to go from 1 to 4, not from 0 to 4. Okay? The radius is x. At any point on here, the radius is going to be x, right? Whatever x is. So it'll be 2 pi times x. Now, the height of this is actually the y value, right? This line right here determines the y value at any point in time. So we can say this is y times dx, because the width of the slices is dx. Now remember, the equation for y in this line is y equals x minus 1. And we can't have x's and y's and dx's in one integral, so we're going to substitute this for y. So if you want to put that in the original integral, that's fine with me, but that's where it comes from, because it's the height of this shell that's coming around. So we have the integral from 1 to 4, 2 pi x times x minus 1 dx. Okay, so now the only constants we have are 2 pi. Integral from 1 to 4, and we're going to go ahead and multiply this out. So that gives me x squared minus x dx. So now the integral will be 2 pi. The integral of this is x cubed over 3 minus x squared over 2, and we're going to evaluate that from 1 to 4. So 2 pi, 4 cubed is 64 thirds, minus 4 squared is 16 halves. And then that's minus this one, which is 1/3 minus 1/2. Okay, so 2 pi times, we can just get all these done by putting them all over 6. So that would be 128 minus 48, and that's minus 2, and that's negative times negative is plus 3. So what do we get out of that? 80. Let's see, 128 minus 48 is 80, and 80 minus 2 is 78. 78 plus 3 would be 81. So 2 pi times 81 over 6. And that goes in there 3. And then that goes in there 27 pi. All right. So let's try another one. Bottom of page 447, it says, use the shell method to find the volume of the solid formed by revolving about the x-axis, the region in the first quadrant. So we're only talking about the first quadrant here. Bounded by x equals 4 minus y squared. Well, that's a parabola that goes out 1, 2, 3, 4. And then if it's x equals 4 minus y squared, if we want to find out what y is when x is equal to 0, that would be y squared equals 4. So this goes up here to 2. So it's this region right here. That region, and it's going to be revolved about the x-axis. So it's coming like this. But we're using shells. We're not using discs. Okay? So we're going to start with a shell. We're going to start with a shell that goes right here. Y equals 0. And then the next one will be like this, and the next one like this, and the next one like this. So if you look at the bottom of page 447, that little cylinder type thing with a hole in it, that's what this shell looks like when it comes down here. Okay, remember this is coming this way. It's coming around the y-axis. So that little cylinder thing at the bottom of page 447 is one of these shells, and we'll add them all up. So we're going to integrate from y equals 0 to y equals 2. We're going from here to here. And it'll be 2 pi, but this time the radius goes from, this is the radius here. So the radius is actually y. And the height of this thing, if you want to call it that, depends on this curve right here. Okay, so that curve is 4 minus y squared. And then, of course, we have the dy. And the reason I put the y equals 0 to y equals 2 is to remind me that my variables in here need to be y's, or else I'll have to change everything around. So here we have a constant of 2 pi from 0 to 2, 4y minus y cubed dy. And now 2 pi, the integral of 4y is 4y squared over 2, so that would be 2y squared, minus the integral of this is y to the 4th over 4. And that's evaluated from 0 to 2. So it'll be 2 pi times 2 squared is 4 times 2 is 8, minus 2 to the 4th is 16 over 4 is 4, and then minus plug in 0 for both of those will just be 0. So 8 minus 4 is 4, times 2 is 8 pi. Okay, once you get used to the shell method, it's actually one of the easier ones to use. It's really hard to picture it. If you put these graphs in Maple and generate a 3D graph, it's really nice to be able to see it that way. Otherwise, it's not so easy to see. And if you can imagine back in the Stone Age when I took calculus, we didn't have anything like that. So I just had to use my imagination and do the best I could to visualize what it looked like. You guys are really fortunate to have computer algebra systems that'll do that for you. All right, on page 448, the last one for this lesson, use the shell method to find the volume of the solid form when the region bounded by the x-axis and y equals negative x squared plus 2x. Okay, negative x squared plus 2x, that's a parabola. Let's see, y equals negative x squared plus 2x. Remember, we can always find the vertex by taking the x value of the vertex is minus b over 2a. So that would be negative 2 over 2 times negative 1. Negative 2 over negative 2. So the x value of the vertex is 1. And if we plug in 1 here, we get negative 1 plus 2, which is positive 1. So the vertex of this parabola, I'm going to say that that's 1 and this is 1 so we can see it a little bit better. Here's the parabola that we're talking about. Okay. All right, that is revolved about the y-axis. So it's coming around here. So you can imagine the kind of shape it gets. And if you look on page 448, it shows you. It's like a bundt cake, okay, without much of a hole in the middle. That's what it looks like. So the radius is going to be here, going from here to here. So the integral will be from 0 to 2. I'm going to go ahead and pull the 2 pi out because it's going to be a constant anyway. The x is this that changes. The radius is this. And then the height will be the y value at any point in there. So the y value is this equation right here. So that would be minus x squared plus 2x. And then, of course, this is dx. Okay, so if we multiply this out, we have 2 pi integral from 0 to 2 of minus x cubed plus 2x squared, and that's dx. So don't forget, all we did was multiply it out. We haven't integrated anything yet. So the integral of this will be 2 pi times minus x to the 4th over 4 plus 2x cubed over 3, and that's evaluated from 0 to 2. All right, so 2 pi minus 2 to the 4th is 16 over 4 is 4, so that's negative 4, plus 2 cubed is 8 times 2 is 16 thirds, and then minus, when we plug in 0 for x, we're going to get 0 for both of those. So then that's 2 pi times minus 12 plus 16 plus 0, or that's negative 12 plus 16 is 4. 4 times 2 would be 8 pi over 3. So it takes a little bit of practice to get used to this, but I'm serious. The shell method is one of the easier methods that we have. We don't have an outer and an inner. We just find out what the radius is going from and to, which axis we're using to revolve it about, and it really is a pretty simple method. All right, so don't forget you're doing odds on